Hey everyone, so in this one I'm gonna start this chapter called Search and Recommendation Engines with LLMs. And as I said, I'm using the book Building LLM Powered Applications by Valentina Alto. So I did read a bit of the chapter, so I'm just gonna do this. And over here, this time I'm gonna keep the files like I'll be pushing on GitHub as well. I did not push previously, so that has kind of gone. So number one is touch. What's it called? We'd be needing requirements .txt, touch .env, touch makefile. And I suppose these would be all. I hope my GitHub has .env in this. And let's see. Yep. Yeah. So okay, we do have a we'll just make a Hugging Face account. I do have one. Okay, we have this. Okay, LangChain. Okay, I think from the last one we've realized that LangChain, instead of LangChain, we should be having LangChain community, because a lot of those files have been deprecated. So we'll be coding with LangChain community. Community. And we'll have to fill up the makefile too. Then python.n, we need this for our environment file. We'll be needing Base Hub, Streamlit, LanceDB, OpenAI. Okay, I am in favor of Mistral also, so we can see that. And then TikToken. I don't know, I haven't used TikToken yet. Okay. This company that recommends items for users. Okay, basically a definition of recommendation system. Collaborative filtering. So let's say I'm A and there's another. I have another friend of mine who's B. We have both have similar interests. So if I like a movie X and he likes a movie Y, and let's say there's another person, not a friend, because if we are friends, then he'll just tell me. But let's who are not at all acquaintance of each other, then if user if let's say he watches Z and both of us had liked a particular movie, then the system would recommend me Z. Similar users. So this is the case. Okay, so they find similar users. So let's say these are the people, and whatever the other people who is similar to who has similar interests to this person has, they would recommend all the same things. The similar item ones. So this is having similarity between A and B, and this is having similarity between X and Y. be in a bit of a trouble, people. What happened? Then there's content-based filtering. These features or attributes. Yeah, I'm just gonna start a timer that even if we study at least an hour. Cancel. Okay, we might not do it on this thing. We'll do it on VS Code. Yeah. Okay. Let me just make the appropriate changes. Yep. So I'm gonna be doing everything over here, and this is my own environment, so I'll be much more comfortable with this. So okay, but obviously I'll be needing a lot of Google searches and stuff. So there goes that. Let's see. Yeah. So content-based features or attributes. Okay, so this goes a bit into item based this thing, collaborative filtering, but this is more like that. If A likes a movie X with the actor Y, so if actor Y is also a comedy film or the same genre and has acted in a film Z, so it recommended to A. So similar actors or similar, it goes a bit more in depth. Hybrid fit. Okay. Does not rely on revenue. Okay, so existing recommendation systems. Okay, this is the boring recommendation. KNNs, we know all know KNNs. Okay. So this is more like the collaborative filtering. Yeah, okay. It's written, it's collaborative. Another type of. So this is item based collaborative filtering. Oh, I have tried this. I have written the KNN code from scratch, and it's computationally quite expensive because it's more like, okay, that just used it upon some data points, and it calculates the mean and then makes a cluster around it. If there's something different, then it has to redo it and calculating everything from scratch. So definitely computationally heavy. Yeah. Okay. Yeah. So this, it'll, you might have to do some sort of like what's it called, data sparsity, that it's the NA values, either you fill them up with something like a mean, mode, median, whatever be the case, or if you remove them, then that's data loss. Yeah, this is also true. It features everything equally, which is not the case in real world. Yeah, you define appropriate value of k. There are greedy algorithms for that, but still, small data sets. That is true. That's true. decomposing a large matrix into two or more similar matrices to uncover latent features that contribute and address the so-called curse of dimensionality. That is good. So we have SVD. We have PCA. I am a very big fan of PCA. Let me just say that. And this one I don't know, to be honest. Let's see. SVD decomposing into three separate where the middle matrix contains single values that represent importance of different components in it. They're used in data compression, dimensionality reduction, and collaborative filtering and recommendation. Okay, reduced by transforming into new coordinate system aligned with principal components. Yes, these components capture the most significant variability of the data, allowing efficient analysis and visualization. You do that through eigenvalues and eigenvectors. Like you make the eigenvalues eigenvectors, and then let's say you have an eigenvalues, so you sort them out, and then you see that okay, so let's say first k eigenvalues represent 99 or 95% variability, or perhaps even 80% of the data. So you sort the eigenvectors according to that, and then you follow that procedure. Then topic modeling, image processing, feature extraction. Okay, we'll be doing image. So let's see this. They have a user maybe matrix wherein they haven't filled these. So because it was from 1 to 5, and then you do the SVD. That represents the constructed matrix, and you do the number of latent factors, that is 2 2 2. Okay, so that's the dot multiplication, reconstructed matrix, and then you show it. So if you see, this is 4.29, this is 4, this is 0, so it's still 0. Then this is 4.7, so this is close to 5, 0 is 0. Then this is 0, but this has been rated as 1. So even though I think he might not have rated it, but still the thing is that the computer rated it, that okay, the user might not have liked it. And to be honest, if it was a highly liked movie, there's a higher chance that the user must have watched it, if given this data has like very movie buffs. Then 3 has 2.27, 2 has this, 4 1.53. User related information, single values. Matrix factorization has been a widely used technique in recommendation, especially when dealing with large datasets containing a substantial number of users, since it efficiently captures latent factors even in such scenarios or when you have personalized recommendations. Oh shit, I have to do the touch.env touch makefile touch requirements.txt. What else is there? Let me just go through. Okay. Okay, so they'll be using a Kaggle dataset for movie recommendation data. We'll probably go through that. Okay, so they are probably making two sort of these movie recommendation systems. We'll obviously look into this and try to make that too. Hmm. Similar to matrix factorization occurs with new items or users that have limited or no interaction history. Since it relies on history, it can effectively provide recommendations. Okay, data sparsity as the interaction matrix becomes sparse need which are true. Okay, yeah, a lot of people don't know about autoencoders, which are really, really, really important. Unsupervised learning, and this the content they consist of encoder and decoder. The encoder maps the input data into lower dimensional latent space representation, while the decoder attempts to reconstruct the original input data from. So this is also another way. It's a does Mistral have a CLI? Let's see if it does, because I'll put that up and then we can Mistral AI. CLI. Um, it does have, but let's not. Okay, that gives me another idea. I want to make a CLI based tool in Rust for Mistral or OpenAI. I'd say if I make one for Mistral, right, using Rust, that would be freaking amazing. But for now, let's just go. Neural networks offer flexibility and ability to capture complex data patterns in data, make them well suited for recommendation systems. That is true. They also require careful design, training, and tuning to achieve the optimal performance. That is also true. Large foundation. So there's also this thing, large foundation models. Let's search if we. Mm, I might buy $1 or two worth of Claude credits. I want to try this. Sorry, Anthropic. I'm gonna try Claude. LLMs can pre-training, fine-tuning, prompting. Okay, I searched about the foundation models for computer vision. It's gonna be an important thing later on. Okay, so they are making a movie recommendation system. Let me search Kaggle for some other sort of data set. Because there's book, books, music, movies, games, food, anime. thinking about this. I think we should start with movie, then move on to movies. Where's the movies? Okay, let's start with the movie data set then. So we have multiple more data sets to work with. Okay, the author won't be giving out the whole thing, but he says that we can head to this particular link on his GitHub page in order to get. So what is he doing for free process? Main step. So what he does is so you must have vote count over vote count plus minimum vote count times vote average plus okay. Why are they not using face again? Facebook AI similarity search. Okay, this is a lot of it has gone. Okay, yeah, so this is a content based one. I'll make this content based system. Then I will make I'll see, I'll make this also. Chatbot and cold start scenario. Makes sense. I'll also be trying out some face and stuff.